In this video, I want to have a look at calculating the probability of multi-stage events. So if we want to calculate the probability of a particular outcome in an event that has lots of stages, then we can just multiply the probabilities of each step, of each part of that outcome. So if A and B are independent events, then the probability of A, B is going to be the probability of A times the probability of B. So our first example says a coin is flipped and a die is rolled. Calculate the probability of landing tails and rolling number greater than 4. So the probability of tails and a number greater than 4. Well, the probability of landing tails when we flip a coin is a half. And the probability of rolling a number greater than 4, well, there's only 5 or 6, so that's 2 out of 6, which is the same as a half times a third, which would give us a probability of 1 in 6. Our second example is a little bit more complicated. So it says Kate buys 5 tickets in a raffle where there's 2 prizes. If 150 tickets were sold, find the probability that Kate wins both prizes or at least one prize. So the difference in this question is that the probability of her winning the second prize depends on whether or not she won the first one. So it's a little bit more complicated, but it's the same sort of process. So for A, we want the probability that she wins and then she wins again. So the probability that she wins first prize, well, she got 5 tickets, so 5 chances out of 150. So that's the probability that she wins first prize. Assuming that she's won the first prize, she only has 4 tickets left when they draw the raffle for the second one. And there's only 149 possible tickets left in the barrel that they're drawing from as well. So we're going to have 5 out of 150 times 4 out of 149. And that's going to give us 2 out of 2,235. For part B, there's 2 ways of thinking about this question. So if she's got to win at least one prize, we could find the probability that she wins both, plus the probability that she wins and loses, plus the probability that she loses and then wins. The other way we could solve that is using complementary events. So the only outcome that's not covered there is that she loses both. So we're actually going to do the probability of 1 minus the probability that she loses, so she doesn't win any prizes. So this means that we're only doing one calculation rather than 3 separate ones. All right, so to do that, the probability that she loses first prize, so she doesn't win first prize, well, she's got 5 tickets, so that means the probability that she doesn't win will be 145 out of 150 times, now there's only 144 tickets left out of 149 left to draw. So if we figure that out, we're going to end up with 49 out of 745. So that's the probability that she wins at least one prize. All right, so that's having a look at multi-stage events.